So in physics, we get this description of a problem. And what we want to do here is that we need to create a motion diagram. So when you're looking at the statement, we want to draw a motion diagram of what? The jogger. That's the key thing. And in all problems, you should always set up a coordinate axis. So right away, because we have to talk about velocity, we have to talk about directions. So I'm going to have to move this over. So then that means here is that this is going to be my west direction. This is going to be my east direction. So we want to take these sentences and create it into a picture. Now you gotta be careful here. There's no way that you're gonna get enough detail in any problem for an everyday situation. Otherwise, it would be an extremely long question. You have to add in certain things here. So let's read it here. A jogger is running east at a steady pace. Suddenly develops, but let's separate this out. So the first thing I want to do here, the jogger is running east at a steady pace. What does that mean? Clearly, the runner is running to the right. And when they say steady pace, that means this jogger is running at a constant velocity. And then it says that there's a suddenly develops a cramp. So if I look at this piece of the sentence, what I got to do now is that I got to make some inferences of what's actually happening. So if he suddenly develops a cramp, is he going to continue to run at a steady pace? The answer is no. We expect the runner to slow down and stop. So that means we're not saying that this runner is slowing down. You're going to have to make inferences of what is happening. Then he is lucky. A westbound bus is sitting at the bus stop. He gets on the bus and enjoys a quick ride home. So the key thing here is that he's going to get on the bus. We expect the bus to be traveling faster than the jogger. So we gotta put our distances to be proper here. So here we go. So I got my direction. Now let's start drawing our picture. We know that he's running. And we're going to say that he's running at what? A constant speed. And then right here, he develops the cramp. So let's label this. This is 0, 1, 2, 3. So at point 3, he develops a cramp. So we know that he's already running at a constant velocity. So we know that the arrows must be the exact same size. Question: what is the size of the arrow at point 3? Is it the same size as it is at point 2? Is it bigger or is it smaller? Well, if he's running at a constant speed, when he develops a cramp, it's not until at point 3. But remember, the velocity at point 3 is about what? The previous interval. That interval is that big. And if that interval was the same everywhere, that speed here has to be smaller here. So then what happens here is that he has to start, or she has to start slowing down. So that means now there's a sudden So then the spacing in the next dot must be smaller. And then in the next dot, it must be even smaller than that. And what we're going to say here is that at this point right here, we're going to say that he stops at the bus stop. And if he stops, we know that the speed must be 0 right there. So now look at my spacing here. If I look at my spacing, look at that the spacing is smaller. So therefore, this speed is smaller. And then right here is where he stops. Okay, now we could try to make the dots smaller and smaller and smaller, but I'm going to stop right there. Okay, all we know is that he stops at that point. So here's where he gets on the bus. So he gets right here on the bus, right here. So what happens? We have to change direction here, and you get on, oops, get on the bus. So what you're seeing here is that now what happens to the bus? Well, let's keep going. There's a westbound bus, so we know that the bus is going to start from rest, right? He can't be getting onto a moving bus. So then he's sitting, he gets on the bus and he enjoys a quick ride. So what do we know about the bus? Well, we know that the bus must be what? It's at rest. So there can't be an arrow when the bus is at rest. So now what happens to the bus? It starts to speed up. And as it starts to speed up, we expect that the bus is going to be moving faster. So there's no arrow in the beginning, but then the bus's arrows have to start getting longer here. So we're seeing an increase in speed in the bus. We expect the bus to be going faster. So then if I look at this thing here, what do I find here? Is that at some point, the bus has to do what? It has to start stopping. So if I look at my dot, I'm going to say, yep, here's the bus, and it's moving faster. And now what has to happen? The bus has to start slowing down. So we're going to say that here, from here to here, is that we have a speeding up bus. And now the bus has to start slowing down. Now I didn't draw my arrow long enough. It has to be longer than the previous one. And so now look at the interval. I look at this interval, and this interval is a big interval. And then I look at the next interval, and I see that this interval is smaller. So therefore, the bus must be slowing down. And at some point, the bus, we're going to say, stops. So here is where he gets back home. So the bus stops and jogger gets off. So here we have the slowing down process. So I should put one more arrow here. And then right here, we say that the bus has stopped. So again, this interval from here to here is constant speed or constant velocity. This interval right here is slowing down. And I forgot to put those before. That is a motion diagram. Any questions on this? So note that you have to make a lot of inferences from what the word is actually telling you.